Hello and welcome to another tutorial on dev.java, and we are looking at the language basics, and we're going to look at the item 3, which is creating the arrays. And we know that arrays are fixed size basically objects, which basically arrays can be of two types: primitive arrays or object arrays. And arrays are kind of like a built-in type. Any array in Java is object, unlike C or C++, that arrays are really built-in types. They're not objects, they're not classes. So an array is a container object that holds a fixed number of values of a single type. So arrays cannot hold the values of different types. The length of an array is established when the array is created, and the length is fixed, which means when you declare or define the array, you have to tell the compiler what the size is. And once the compiler knows that, it allocates that amount of memory that corresponds to size, the total size. And after that, you can never change the array, right? After creation, its length is fixed. And the nice thing about array is that Java, basically in the Java heap, the way JVM manages these arrays is everything is a contiguous block of memory, very much similar to how C and C++ handles built-in array types, right? And again, these arrays are static arrays. They are not dynamic arrays. The length cannot shrink or grow at runtime. You have seen an example of arrays already in the main method of the hello world, which is the string args, right? And that's array of references to strings. This section discusses arrays in great details. Now, just like any programming language, the indexing in Java also starts from 0. Again, that's a convention. The reason is that 0 is easier to start with. It's just computers like zeros better than, for example, starting from 1. I believe in MATLAB, for example, arrays start from 1. But in most programming languages like Java, C, C++, etc., even in Python, index of the arrays starts from 0. All right. So get used to the notion of starting the index from 0. And if the length of the array is 8, the index goes from 0 to 7, right? Just be cautious about this. And if you want to get the value of the element at index 5, at position 5, basically you have to give it the index 4, right? Each item in an array is called an element, and each element is accessed by its numerical index. And that's a very nice thing about arrays or primitive types of arrays or built-in arrays. And the reason, the other thing is that the retrieval of the value or the element is very fast, because all the data in the memory that is allocated to in this array is contiguous. It's a big block of contiguous memory. So the runtime, the JVM knows how to quickly jump from one element to another, because it knows the offset. It knows the size of each data. That's the whole point of having a statically typed array. The size of each element is known to JVM, to the runtime. And then JVM knows if you want to index the second element, it has to move from index 0 to to index 1 with this number of bytes, right? As shown in the preceding illustration, numbering begins with 0. You have to be always cautious about this. The sixth element, for example, would therefore be accessed at index 5, right? The following program, array demo, creates an array of integers, puts some values in the array, and prints each value to the standard output. Now, before looking at this example, let me also create my own example. Let's create an array, call it basically... let's see, let's call this array. Let's have a main method. Let's call this arrays, for example. Or actually, let's just call it array. I don't want to use arrays because arrays are a built-in class in JDK. So I just use array, right? Now, in the main method, arrays in general in Java, and also in C++, we have two types of arrays. Two types. One is primitive type arrays, right? Two is reference type arrays. So basically, primitive type arrays means all the elements are one type of primitive. And again, Java allows the existence of primitive types. So for example, I can say int array x equals or a. Let's call this a1. And then here. So I am declaring an array, and what this means is that there is any variable, again in Java, has to have a type, and we're saying that the type of this variable is an int array, so an array of primitive types, right? But right now we haven't actually initialized this. We haven't told the compiler what values or how much memory to allocate. So the compiler at this stage doesn't allocate anything, any memory, right? Because it's just the fact that this is an empty array. And we said that arrays, even primitive type arrays, are objects. So this is another difference between Java and C++. So the first difference between Java and C++ is that in C or C++, you use this notation, int a1, and you put the square brackets after that, after the name of variables, right? So I believe you cannot do this kind of notation. You cannot say int a square bracket, right? So you have to say int the name of the array and then the square bracket after that. So you tell the compiler that I'm declaring this variable as an array. The other thing here is that if I do a sysout on this array a1, right now this is going to give us a compilation array. That's because, as I mentioned before in the previous lectures, whenever you declare a local variable, you're declaring it. You have to initialize it. Otherwise, if you use it before you initializing, then the Java doesn't allow you to compile it, because it says that the local variable a1 has never been initialized. You have to initialize it. So how do we initialize arrays? So initializing arrays. In Java, we have two options. One is empty array. You just declare the size. So we're going to say that a1 is new int array with size 3, for example. So the compiler goes ahead and allocates memory that can occupy basically 3 integers. Integers in Java are guaranteed to be 32-bit or 8 bytes, so we have 24 bytes associated with this. But the actual size of the object in the memory is more than 8 bytes, because obviously int array is an object. It has to have some headers that tell the, for example, garbage collector what's going on. So objects in Java are not the purely, even arrays in Java are not purely, the size is not exactly the size that you would expect. So you would expect 3 integer is 4 bytes, right? 32-bit is 12 bytes. But that's not the case if you actually, the implementation in JVM, the size of in this array is going to be a little bit more, because objects in Java have headers, a little bit of headers. But for example, this is another difference between C++ or C with Java. In C or C++, arrays are really nothing but a block of memory. They're not objects. So basically, I'm going to write this here. In C or C++, this you have the size of operator. If you put this size of a1, you definitely get 3 times 4, which is 12 bytes. You get exactly 12 bytes. So in C or C++, arrays are not objects. They don't have any basically headers or any extra bytes that carry more information about them. For example, array in Java is still a built-in type, but you have the concept, you have the dot operator. You see, they inherit from the object class. They have the clone, hash code, toString. So these array types, these are built-in types, but you still they inherit somehow from the object, and they have this final field length, and this field is final. So this is extra information, right? So the arrays have extra information that can tell you what the length is, and know that length is final, which means if I cannot assign it like this, and the compiler throws an error, says that this length is a final field, and we know that the final field, when it's initialized and has a value, the value can never be changed, right? And it's a public, but it's not a static. Obviously, different instances of an array can have different lengths, right? So it's not a static field. It's a non-static field, but it's final. So as soon as you create the object, in this case, it's an array object, then the length is determined. That's why you have to statically say the length of the array at when you declare or define it. When you create the array, you have to tell the compiler what the size is, or the compiler has to be able to deduce it. Now, another difference here is that, so this doesn't work. This doesn't work, right? The other thing is that, how do we assign values to the arrays? Filling up the array. So there are many ways. One is element by element. So element by element, which means we say that a1 at index 0 is 1. It has to be integer. A1 at index 1 is 2, for example. A1 at index 2 is 3, right? And then this works if I try to access another index 3. This seems to compile fine, which means the compiler doesn't check if you're accessing at compile time. It doesn't care if you're accessing some index which is invalid or outside the bounds. But then if we run it at runtime, the JVM actually checks that, and it throws an array index out of bound exception. So if you try to access a element outside, then you get the array index out of bound exception, which is a very famous array. I believe every Java programmer has at some point encountered this kind of exception, array index out of bound. Now this is another difference with C or C++. So in C or C++, the compiler and the runtime, so the compiler does not care, and because arrays are not objects, so no bound checking happens at runtime. Also at compile time or at runtime, no bound checking, which means basically when the compiler sees a1 3 equals 4 in C++, it just instructs the CPU to retrieve the value of a1 plus basically index 3, and this is integer, basically 3 times 4 bytes, 3 times size of int, right? And remember, in C++, a1 is a pointer. In Java, a1 is a reference type, and we said that in Java, references are syntactic sugars for pointers, just because you don't need to deal with dereferencing them, right? So basically what happens in C++ after you compile such a code and you're trying to retrieve an access index beyond the bounds of the array, the compiler doesn't care. At runtime, it just says that move 3 times the size of the type of the array, which is int, and then offset the pointer to the beginning of the array. The name points to the beginning of the array, dereference it, and assign the value on 4. And this most likely crashes your application in C++ because you're accessing some memory that can be dangerous, that can be used by other applications, etc. Right? Now in C++, obviously in Java, even trying to access or just read the value which is outside the bounds, it also gives you array index out of bounds exception, right? But then in C++ or C, you are definitely allowed to read from the invalid memory address. It doesn't cause any harm. You're just getting a garbage value, right? So in C++, this works fine. In C++ or C or C++, this works fine. But you get a garbage value, right? Oh, another difference here is that when you declare the array in Java, the compiler goes ahead and initializes all the values with the default value of that type. For example, if it's a primitive type, we've already looked at the default values for primitive types. Int is 0, all the bits are 0. Reference types, they're all null because all the bits 0 of a reference type is a null. So if I sys out a1 at index 0, I have defined it, so no problem here, and I already know that the length is 3, but I haven't assigned any value to the 0th index. I haven't initialized it, and we get 0, right? So the default value. So Java compiler, or basically either Java C or JVM at runtime initializes the array to default values, right? Based on the type you choose, you get the default values. If I go and say that this is double, right? Obviously I have to also change the declare here to double, and then now I get 0.0, right? The default value is float 0 or double 0, right? So let's go back to int. In C or C++, when you declare an array, whether on a stack or on a heap, using the new operator in C++ or C, in C++ actually, in C you have to use malloc or something like that. So let's say in C++ you use new, the compiler doesn't do anything at runtime. It doesn't, nothing happens, which means no extra work is done, which means the default values are garbage values. So unlike Java, that guarantees that you always get the non-garbage values, at least the default values of that type. In C++ or C, whenever you define an array, you set the size, you still get garbage value. You still get garbage values, right? With this kind of new operator in Java, in C++. Now obviously when you declare something with new in C++, you have to then delete it using delete array. So in C++, once we want to deallocate the memory on the heap, you have to use the delete operator that comes with arrays. In Java, there is no such thing. As soon as this array goes out of the scope and there is nothing referenced it, then the garbage collector can kick in and then basically free this array, right? So no problem in Java with memory management, everything looks fine. And then the other thing is that arrays are built-in types, and there is really no class definition associated with this. So this is another thing that I want you to really understand. There is no class object or class definition associated with arrays, array types, right? So whenever you have a T array, this translates into some built-in types or some type that is defined inside the JVM. It's internal to the JVM, which means so it's some sort of internal type inside the JVM, which means you can never subclass an array type, right? You can never say that. For example, you can never say that I'm creating a class my array which extends, for example, T array, right? This kind of doesn't work, because this extend only works for subclassing arrays, and we can actually go ahead and test it. So array subclass, let's see if we can actually subclass an array type. So let's say this extends I can extend for, let's see if we can extend an int array, and this doesn't work, right? Even though int array defines a type, defines an object type, it doesn't have a class definition, which means you cannot inherit from these array types. Even if I say, for example, a string array, it doesn't work. So you cannot extend an array type, right? You can't do that. But for example, you can inherit from dynamic arrays that Java provides. For example, array list of, let's say, integer, and we have to use the boxed primitives or wrappers. At the moment, there is no specialized primitive generics here. This works because array list is not a built-in type. It has a class definition associated with it. And as long as it's not a final class, you can inherit from it and modify it. All right. So this is another important note, that you cannot extend a built-in array type, right? You cannot do a class with the name extends int array or a string array or whatever, because they don't have a class definition associated with them. So the following program array demo creates an array of integers, puts some values in the array, and prints each value to a standard output. So this is our main method, and then we declare an array. Note that this is declaring. So we just tell the compiler, hey, then this variable name, an array, corresponds to an int array, right? That's it. We're not telling the compiler to allocate memory. But after that, we are initializing or defining the array, which means now we say that this variable, you know what the type is. Now I want to allocate 10 integers that this reference, this array variable, which always points to the first index, right? And then we initialize using the index. Obviously, if the size is large, you want to put it in a for loop or something. We will look at the loops in the future lectures. So you access the elements using the indices, and the index basically starts always from 0. And then element at index 0 is array index 0, array index 1, all the way, etc. So you can assign the values to the array elements with this notation, with the assignment operator and then the index value, or you can read the values from the array using the index operator, right? Array and index 0, index 1, etc. And as you can see, we get the indices that we expect, right? The values. So with the array notation, with the index operator, you can either assign values, you can write to the array, or you can read from the array. Both are supported. Even if you define the array as final, you can always use the assignment operator, because unfortunately the way final works on objects in Java is that it doesn't guarantee const correctness. So which means the bytes in the memory that are associated with this object can be changed, can be mutated, but the variable itself cannot be reassigned. So that's the meaning. And we will look at this kind of const correctness concept both in Java and C++ in the next lecture. So to wrap up this lecture, in a real world programming situation, you would probably use one of the supported looping constructs like for loop, mainly for loop, to iterate through each element of the array rather than write each line individually as in the preceding example. Obviously, especially if the size of the array is large. However, the example clearly illustrates that the array syntax. You will learn about the various looping constructs like for loop, while loop, do while loop in the control flow section, which we will look at it in the future ones. So I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.